Okay, let's get started with this. Okay, and let's go with this number 9, and this is an easy empirical formula problem, and gives you the gram of each one. This is the way I like and would like you to do it, because it's I don't know, I think it's easy organized in one night. First of all, we got the grams of each one. We don't need to assume 100 grams because it's not given in percentage. When I give you percentage, you have to assume 100 grams, because what is what you want to do? You want to look as the percentage of each element, the proportion of each element in a formula, in a compound, doesn't change because of the law of definite proportion, no matter the size of the sample. You can assume 100 grams. You can use the grams given, and using that, we can find the ratio. So the first thing we have to do is calculate the moles. The second thing, those are the steps. First thing, calculate the moles. Second thing, calculate the ratio by dividing by the smallest one. If we have a decimal, we have to be careful not to round it. Okay, so we'll get there. 7.5, let's start it. 568 grams of carbon. Atomic mass is 1 mole. You have to do it for each element. 12.011 grams. And that gives you 0.63009 moles. 0.63009 moles. Hydrogen. Hydrogen, you got 0.881 grams. 1 mole. One mole on top, and on bottom 1.0079 grams. Cancels out, and that gives me 0.87874,095 moles. I did these calculations. That's why I started several hours later. And on oxygen, you have 1.5. Here it is. You should have the 1.551, 1.551 grams. And then you, of course, smaller mass goes on bottom, the grams goes on bottom, and it's 15.9994 grams. I'm going fast on this, and you're going to ask me, where did you get the 15? Go and look at the periodic table. This is the atomic mass, the molar mass of each element. Okay, and we divide it to get the moles. And then we're going to divide it by the smallest one. Okay, I can't go slower because we're going to be forever here. 0.9694 moles. Now we have to divide it by the smallest amount of moles. Okay, and the smallest is the oxygen because it's 0.09. So this, we're going to divide it by 0.09694 moles. 0.09694 moles. Moles and moles. And 0.09694 moles. And you can, and this is 1. The oxygen is 1. The hydrogen would be 9.01, which in this case you can round it to 9. and then the carbon is 6.4998, which is 6.5. You cannot round it. If you have a 0.25 and lower than a 0.25, yes, you can round it. If you have a a 0.75 higher than that, you can round it. But if you got in between this range, you cannot round it because you're going to mess up the ratio. That's why. So if you got, how many times I say that, if you got a 0.25 and a 0.75, it's a quarter and 3/4. You multiply by 4 to eliminate those decimal. You eliminate it. If you multiply, and then you have to, but you have to multiply all by that. If you have a 0.5, like here, you multiply by 2. And if you have a 0. Well, it's not really 0. Any 0.75, 0.25, 0.5. If you have 3, 3, 3, let me leave the 0 here, but it's the same. And this you multiply by 3. So those are the 3 that you use: 3, 4, and 2. In this case, this is a 0.5, 6.5. So you need to multiply by 2 so you get the whole number. This is like saying is 6.5. And this, but you need to multiply everything by 2. And this the same, because if not, you'll mess the ratio. So this is 2. This is 18. And this would be 13. And you got your whole numbers. So the empirical formula would be carbon. That's why I do it like that. Carbon, 13. Hydrogen, 18. And oxygen, 2. Okay, let's continue with the next problem. These are short ones. Okay, calculate the molality, lowercase m, remember, lowercase m. And molality, by the way, the formula, no, I'm not going to give these formulas, is number of moles of solute divided by kilograms of solvent. So you got 185 molar with a density. So let's write the data we have. It's 1.85 molar with a density of 1.08 grams per milliliter. Now this is a little bit tricky because, well, is it giving me the liters of solution? No. If it giving me the solvent, the kilograms of solvent, no. But you need to see, why are they giving all those things like the density? How are you going to use it? And where's the liters of solution? You get the density, but where's the liters of the grams? Okay. This is the difficult part sometimes. And it's, okay, they're not giving you anything, but you know the molarity is number of moles. You can do this per liters of solution. That means that if you got 1.85 molar, You got 1.85 molar. That means 85 molar. That means that you got 1.85 moles in 1 liter. Is that right? 1.85 moles in 1 liter in 1 liter. So if we take 185, we can use our volume as 1 liter, which is 1,000 milliliters. So what do we want? Okay, to calculate the molarity, we need the moles of solute. Do we have them? Yeah, because we have 185 moles of the solution NaCl in how much? 1 liter of solution. So we have the solution, but the solvent we don't. So, and the other thing is that the solvent is in kilograms. But what do you think they give me the density of the solution? Do you got the volume? Yes. This would be the volume of solution would be equal to 1,000 milliliter. Okay, so if you got the volume of solution and you got the density, can you find out the grams of solution? Yes, and you're going to say, what are we doing this for? Okay, I'll tell you why. Okay, we have here, because this is what we're going to do. Okay, assume 1 liter. Okay, assume 1 liter, 1,000 milliliter. And you got 185 moles. So you got already the bottom of the denominator of the formula. Now then, what are you doing with those liters? With density, calculate the mass of the solution. With density, calculate the grams of solution. And what are we going to do with those grams of solution? We know that the solution is equal, the grams of solution is equal to the grams of solute plus the grams of solvent. So if we have grams of solvent is what we need for the formula, kilograms of solvent, do you see it up here? So if we got grams of solution from the density and the liter, and we got the grams of solute, where can you get the grams of solute? Don't you have the moles? Yes, we do. Okay. So we got, what we want to know is what we need. And here, what we need for this problem is the grams of solvent or kilograms of solvent. And we don't have it. And that's what I'm trying to do with all this. I have the moles, yeah, because as I said, 1.85 molar means that you have 1.85 moles in 1 liter. Okay? You got the moles. Okay, you got 1 liter because you assume 1 liter, that's correct. So it's 1,000 milliliters, so you got the volume of the whole solution. Be careful with the volume of the whole solution and with the density of the whole solution. There must be a reason why they're giving it to you, and it's because you can find the grams of solution. But you need to find out the grams of solute so you can subtract it to the grams of solution, because how I said, grams of solution, that's what we're going to find out here. And I'll do it in the equation like this. Is equal to the grams of solute per grams of solvent. So what do we need to do? Okay, so now, then after we calculate the grams of solution, we calculate grams of solute, so we can subtract it. And then finally, we calculate the grams of it. It's complicated. Of solvent. And then we go and calculate and convert it to kilograms of solvent. All this in one problem. And I'm going to need space. Ooh, yeah. Okay. So let's go ahead and get this. So the first thing now is, okay, let's use the density and the 1 liter to 1.08 to calculate the grams of solution. So the grams of solution is going to be, if you know density is equal mass over volume, okay, and I'm going to erase like that because I don't know what's in time. Volume by the density gives you the mass. That's it. You multiply. So the mass or the grams of solution, be careful, is the density of solution, which is 1.08 grams over milliliter. And now we convert that liter that we assume to 1,000 milliliter. So we can use it here. And that gives us 1,080 grams of solution. Okay, we got something done. Now, to remember, we got the moles, but we need the kilograms of solvent or the grams of solvent. So to calculate it, we have to use this formula, what I was telling you. So what will we need? We need the grams of solute. Can we get it? Yes, of course. You got the moles of solute. Remember, we got 1.85 molar in 1 liter. Once we assume 1 liter, we know that 185 is the number of moles. So the number of moles of NaCl is going to be 1.85 moles. So this, you can convert it to grams. So the number of grams would be 185. We're going to multiply moles, sorry. This I have to, it's too awful. 1.85 moles. We use the molar mass. And the molar mass of NaCl, okay, moles, molar mass of NaCl, if you want, I can write it here, okay, it's 22.98977 plus 35.453 is 58.44277 grams per mole. Okay, so using this molar mass, we convert the moles, the 185 moles in 1 liter, we convert it, 185, we convert it to grams, and how? Grams on top, because that's what we want, 277 grams, and the 1 mole goes on bottom. We cancel it out, and that gives us 108 Let me double check this for a second. I'm going to put pause and let me check this. It gives me the answer, but yeah, that's right. It is because it's the numbers that are, you'll see. So it's going to be 108. It's very similar, like the density is 1.08, 0.119 grams. Now we got the grams of solute. We got the grams of solution. Now we're going to use the little formula I show you, that the grams of solution equals the grams of solute plus the grams of solvent. So grams of solute, let me write it down, of solution equals the grams of solute plus grams of solvent. Okay, what are the grams of solute? Grams of solution. The grams of solution, we have it, okay? And it was from the density, 1080 grams. 1080 grams. The grams of solute, we got it here, 108.119 grams. And this is what we find, what we need to find. So this is going to be, the grams of solvent would be 180 grams minus 108.119, and that gives you 971.8809 grams. And convert it to kilogram, we divide it by 1,000, move the decimals place 3 to the left, and it's 8809 kilogram. Okay, let's go now with this. We got the kilogram. Now finally we can find the molality, and it was, remember, 185 moles, okay, 185 moles of NaCl. We divided by the kilograms of solvent, which is 0.9718809 kilogram, and that gives you, sig figs and everything, 1.90 lowercase m. Finally, this problem. Okay, 11. Calculate the molality. Calculate the molality. Again, molality. And it's 36% of 36% by mass of KBr. Hold on. 36% of by mass means a percentage is 36.7 grams of KBr in a total of 100 grams of solution. Right? Again, if the problem is asking for molality, is number of moles of KBr in kilograms of solvent. But the kilograms of solvent, be careful, it's not the same as the kilograms of solution, of the grams of solution. Again, we have to use the little formula, and it's that the grams of solution equals the grams of solute plus the grams of solvent. And to find out the grams of solvent, because that's the one we need in this problem, it's equal to grams of solution, 100 grams, remember? And solute would be 36.7. 36.7 grams plus grams of solvent. So the grams of solvent would be 100 grams minus 36.7, and this is gonna give me 63.3 grams of solvent. Now we know in the formula we have to use kilograms of solvent. So it's gonna be 0.0633 kilograms solvent. Just for your recommendation, if you don't understand when I got that, just review the conversion between liter, milliliter, density formula, grams to kilograms. And then of course, we had to calculate the moles because here it's not given. It's 36.7 grams of KBr. So to use for the formula of molality. So the moles would be equal to 36.7 grams. Now the molar mass of KBr, again, potassium 39.9. I remember, and Br is 79.904. So the molar mass of KBr is 119.0023 grams per mole. So this is going to be 1 mole on top, because we want moles, on the bottom 119.0023 grams. Cancels out, and this gives you that the moles of solute is going to be 0.308397 moles. Now what we have to do is use it in the formula. We got the kilograms of solvent, we got the moles of solute, so M would be 0. The number of moles, 308397. Maybe you use exactly all the decimals, you don't get exactly one, because my answer is with less decimals. I use 0.3084. 633 kilograms. Yeah. And the molality is equal to 4.3 significant figures M. Just remember, I always give you in the sig figs. Okay, so that's the answer. The next one, if you wish to prepare 163 M, molarity is equal to 1.63 M of solution of NaNO3. To what volume in liters would you have to dilute? Okay, so what they asking you? The volume of dilute. They're not asking you how much you have to add. 19 point, this is the volume of the concentrate because it's 220. So the molarity dilute, this is the concentrate, 2.20 M. And you can see it right away. 220 concentrate, less lower molarity, less concentrate, less amount of moles per liters. And this is 19.6 milliliter. No exponential and in liter. This is easy. It's volume of the dilute by molarity of the dilute equals volume of the concentrate multiplied by the molarity of the concentrate. Volume of the concentrate would be 19.6 milliliters multiplied by 220, M divided by the molarity of the dilute, 1.63 M. M and M cancels out. Volume would be, we don't need to do the conversion now, 26.454 milliliters. So the volume, you convert it to liter, you divide by 1,000. Zero, I'm not going to go through the conversion. 2651. I hope you know how to do that at this point. Liter. Okay, so that's the answer. It says no exponent. It's not 2 by 10. No, just enter this number. Okay. So an aqua solution of 30%. Let's stop it now.